Hello, in this video I'm going to demonstrate how to use the assignment model in TRANSYT. This network shows a series of connected junctions, or intersections if you prefer, each with their own origin-destination matrix for traffic flow. I'll just zoom in on the one on the left here, show you the values within the matrix, and here you'll see that the flow values in here in the OD matrix are the default 50 PCUs per hour. And if I click through each of the local matrices one by one, you'll see it's the same for each of these here. So I'll close this down. If your traffic demand flows have been collected on a network-wide basis, TRANSYT has a tool to help assign this traffic flow to the network of junctions. So we'll start by adding in a wide area matrix to this existing file. If I move down to the lower horizontal toolbar of the network diagram, you'll see the icon for the OD matrix. If I click on there, you'll notice I can add in also a new wide area matrix. So I'll do that. I'll just position it there. And by default, it will add in one location. So the wide area matrix is represented by this green square, and the locations that go with that wide area matrix are the green diamond shapes that are shown there. If I want to add more of these in order to fill up the whole of this junction with the required number of locations, I could right click on it and add in a new one, but it's actually easier simply to go down here and select a location on there, and now wherever I position the mouse I'll create another location. So I'll just position one there, working clockwise around the network, one there to move the network over a bit. Sorry. Come back to that one. And now just move the first one into position, and then move this slightly rogue one back into position here. So that's the locations been added in. So each of these diamond shaped icons denotes an origin point and destination point for the network-wide demand flows. The green shading shows the origin destination locations that are associated with a wide area matrix. Please note you can have more than one wide area matrix in one file. This capacity can be used when, say, you have two designs of the same network in one file. The next step is to connect these green locations into the constructed network. This is done using the connector tool. Again, taken from the lower horizontal toolbar. Click on connect. And now if I zoom in, just to make it a bit easier, I can connect up my first wide area location into effectively the back of a local OD matrix location. You'll also notice that it has a grey double-headed arrow indicating these are bidirectional. So you only have to connect them up in one direction, and the order in which you do that doesn't matter. Unlike for the local matrices connected to the network, or traffic streams connected into the back of another traffic stream, you do not have to do them in a particular order. These ones are done in the order of whichever way you like, while for other purposes you'll normally do it from upstream to downstream to ensure that the arrows are going in the right direction. So let's finish these off by connecting each of them up. By the time I finish, I will have established almost a coating around the outside of the existing network in the form of these locations. And that's exactly what I want to do. So everything within that zone now is under the sort of nominal control of the wide area matrix. If I click on the matrix, you can see how they're all connected up to that one wide area matrix. Just a reminder, looking at the wide area matrix of flows, that flows in here in the local matrices are currently the default values on there. So I'll just leave that on the screen for now. If I now click on the wide area matrix, there's no equivalent of the OD flow in the vertical toolbar here, so you do need to right click on it and go to the assignment tool. This will bring up the OD matrix for the wide area matrix for the assignment tool. This is blank, and I obviously could start to fill in numbers there, flows manually. but in fact I've prepared earlier a spreadsheet like this containing my traffic flows. So all I need to do is select this, select copy, and move this out of the way, click on the top corner there, and then use the paste option here off the main menu. And lo and behold, I have a fully populated wide area matrix. Once the traffic is added to the wide area matrix, the flows can be assigned to the local matrix using the button in the bottom right hand corner. So let's do that. I have an error, so I have not connected one of these up. Bear with me, and I'll check which one. It's this one here. Errors are gone, ready to go. So reassign, this time it'll work. And there we have it. The flows is assigned using a journey equilibrium model, and as such requires TRANSYT to run twice in order to assign the flows. You may have noticed that when the little progress bar came up on the screen. And you also may have noticed that I emphasised the term assign. In TRANSYT, we exclusively reserve that particular term to revert to the use of the journey equilibrium model, while we use the term allocate or allocation for when traffic flows from a local OD matrix are shifted onto a TRANSYT network of traffic streams. That's done via a hidden underlying network structure. This is just to avoid any confusion between the two terms. It's easier that way. In fact, the equilibrium model also constructs its own hidden underlying network structure so that it can carry out the complex business of assigning traffic to the network. So it's a bit like a swan swimming on a pond, elegant above the water, but really quite complex and involved underneath. So now let's look at one of the local matrices. And you can see here the default flows have now been replaced. And as local matrices tend to do, they will automatically allocate the traffic on this matrix onto the network itself. You don't have to do anything else in addition. This is set up by the fact that this auto calculate option is set to true. And you also can check to see that the flows have actually all got onto the network by selecting the resultant flows tab on here, where you can see all the flows that were on the entry flow tab have been allocated to the network. And it's also fairly obvious if you zoom in on the network diagram. By default, these connectors are actually showing the total flow coming into this traffic stream, 378, in this case 447 there above it. And also, you can also go into the traffic stream data, flow data itself to check as well if you want to. So if I went into that traffic stream and went in here, the 378 is the same number that you're seeing on here on the connector. So what we haven't done here though is we haven't re-optimized this network. We've added lots of extra flows onto it, but it's just running with the default timings that are in here, which is probably more or less spread the green times between the different stages before we started. So what we'll do is do a full run, optimized run of the network, and that will bring down the PI value, and the highest degree of saturation has also come down to below 90%, which is very good. This network is performing well now. So you can see how the assignment process has populated each local matrix, and these in turn automatically allocate the traffic to the network. Just one word of warning regarding the repeated use of the assignment model. You should avoid repeatedly alternating between assignment and signal optimization, as this can lead to a result where the extra green time will be given to the routes with more traffic, and the assignment process will subsequently push more traffic in that direction, and so forth. It will repeat the same thing. You'll get more green time being allocated to the traffic stream for more traffic, and then the assignment process will then give it more traffic again. So it's self-fulfilling prophecy, as it were. Now, just to finish off, I also want to point out that local matrices also have the option of using a journey equilibrium model, and can be used at large complex junctions where drivers have a choice of routes within the area covered by that one local OD matrix, such as at a magic roundabout. I'm Jim Binning, and that concludes my presentation. Thank you for watching.